Welcome everyone to the AutoML and AWS workshop, where Soyan and Hadas, your workshop leads for today. This workshop is designed for data scientists at any skill level. Whether you're a beginner or an expert, we hope you find value in participating in this workshop. So by the end of this workshop, you will be able to use AWS SageMaker to automatically build and train a model. One of the key things when you build a model is to understand the data set you're working with. So SageMaker generates a lot of reports before and after training a model, and at this workshop, you'll learn what kind of insights each generated reports give us. So what is AutoML? AutoML stands for Automated Machine Learning. AutoML, in a nutshell, is a powerful tool that enables people like data scientists and developers to automate various aspects of the machine learning pipeline. So it streamlines the process of developing, deploying, and managing machine learning models. Now let's explore why you should consider using it in your machine learning projects. AutoML brings several benefits that can enhance your workflow and productivity. So first of all, AutoML provides increased efficiency. By automating time-consuming tasks, such as like data preparation, feature engineering, algorithm selection, training, tuning, and inference, it frees up valuable time for data scientists and developers in a working environment. So now you no longer need to spend hours on low-level tasks. You can now focus on more critical aspects of your projects. And another advantage of AutoML is that it lowers the barrier to entry for machine learning. So it makes machine learning more accessible to a wider range of individuals, regardless of the expertise level. AutoML abstracts away the complexities of algorithms and model building, so it allows users with varying levels of experience to harness the power of machine learning more effectively. So transparency. AutoML also brings transparency to the machine learning process. You gain visibility into the automated steps taken during model development. So the transparency allows you to better understand the decisions made by the system and facilitates interpretability, which is crucial for building trust in your models. Last but not least, AutoML is highly scalable. It enables you to tackle large-scale machine learning projects efficiently. So by automating repetitive tasks and providing a framework for managing and deploying models, AutoML empowers you to handle complex and resource-intensive projects more effectively. So who uses AWS AutoML? Turns out a lot of the companies use AutoML, such as like Tinder, Grammarly, and Hotels.com. So the previous CEO of Tinder said this about Amazon SageMaker. Behind every Tinder swipe is a system that manages millions of requests a minute. Amazon SageMaker simplifies machine learning, helping the development teams to build models for predictions that create new connections that otherwise might have never been possible. Also, I'm sure most of you guys are familiar with Grammarly. I've used it before too, like on my essay assignments, but for those of you who don't know what Grammarly is, Grammarly's algorithms help people communicate more effectively by offering writing assistance on multiple platforms across devices through a combination of natural language processing and, advanced machine learning technologies. According to the technical lead at Grammarly, they use SageMaker's flexibility for their different production requirements. So they run inferences on SageMaker itself, or when they just need the model, they download it from S3 and run inferences for their mobile devices.
So before we jump into our demos, there are a few more general things we need to go over. So the main platform for automated machine learning in AWS is called SageMaker. It has a lot of capabilities that are really useful for data scientists, business analysts, and really anyone working with data. One of the main benefits is that it's easy to connect to data sources in AWS, like S3, which is great because a lot of companies use AWS or other cloud computing platforms. Once you have your data, SageMaker can help you with any part of the machine learning lifecycle. For example, it has tools to help explore, analyze, and query data. You can also transform your data using different feature engineering techniques to prepare it for model training. Then there's building the models themselves. For a lot of common tasks like text classification, they have built-in algorithms and models, but you can also train and tune your own. Once a model is trained, SageMaker can analyze model metrics, bias and model predictions, and compare the relative performance of different models, among other things. As a last example, SageMaker also streamlines the process of deploying models by making it really simple to deploy to a SageMaker endpoint. So now let's take a look at the SageMaker dashboard to see what the platform looks like. So this is just the dashboard for SageMaker for my own AWS account. So this is a great starting point for accessing all SageMaker tools. It's good because you can use it to monitor any processes you have running. So for example, we can see here in the last 30 days, I had 110 training jobs created and completed, a hyperparameter tuning job, and we can also see processing jobs and batch transform jobs. So this is just great to see everything that's currently happening. And then if you wanted to see any of these processes in more detail, you can use the menu on the left. So for example, for training jobs, if we go under training and then training jobs, we can get more detail about the jobs that completed. Okay, let's go back to the slides. So this is a list of all of the main tools available in SageMaker. In blue are the ones we're going to be covering in the workshop, which are SageMaker Studio, Autopilot, Clarify, and Data Wrangler. But as you can see, there are a lot more that you can explore on your own afterwards. And then, of course, before we get started with the demo and see how AutoML works in AWS, we should figure out how we can get started with using these tools ourselves. So you can walk away from this presentation with some skills. So the first thing you should know is when you create an AWS account, you get access to AWS Free Tier for 1 year. So this is great because you have access to a lot of different AWS resources and services for free where they would otherwise be paid. You have to be careful with the fine print here, though, because they have very different policies for different services and resources, and it's not exactly that it's all free for 1 year. So for example, for SageMaker specifically, we see that it's only free for the first 2 months, even though it's included in that 1 year free tier. And you can see in the screenshot there the specifics of how much is free. So we see 250 hours per month are free for a T2 medium notebook instance. So you just have to be careful to make sure to stay within that free tier. On that note, we're just going to talk a little bit about how to avoid billing in AWS. It's just an important skill as a beginner because when you create an AWS account, you do have to attach your credit card. So if you exceed the free tier, you will be charged. So there are just a few preventative things you can do to make sure that you're staying within the free tier. So the first thing is within your AWS account, there is a billing page or billing console, which you can use to monitor the usage of resources in your account. So one great thing is that it shows you the different free tier services you have access to and their usage to make sure you're still staying within the boundaries of the free tier. But there are other things you can do so you're not just constantly checking this billing page. So if we go to the next slide, you can create a budget. So again, in the billing console, you can set up an email notification for when whichever budget you configure is exceeded. So for example, for my AWS account, I have a budget of $0. So I get an email whenever I exceed $0 in my AWS resource usage. You can also set up a CloudTrail in CloudWatch. So basically what this is a log system. So logs will be created when you use resources for how you use them. So you can monitor your resource usage and also get notifications about it. The last thing you need to make sure you're doing to avoid billing is to make sure to delete resources when you're done using them, because if not, there's a chance that AWS could charge you as if you're still using them. So just whenever you're done with the process, just make sure you go through SageMaker and ensure that nothing's in use is deleted. So let's just talk a bit about what our expectations are for the demo. So since we just explained about billing, we're just saying you can follow the demo and create your own AWS account, but just follow at your own risk because it is a little bit tricky to make sure you're staying within the free tier. But if you follow carefully, it should be okay. Make sure all of your resources are deleted properly at the end of the demo and make sure you're following those billing guidelines. One thing to mention also, if you are accidentally charged at the end of the demo, definitely contact AWS because they might be able to do something about your charge. You can also come back to these demos at a later time if you don't want to follow along right now, when you have more time to sit down and follow more carefully at your own pace. So if you do choose to follow along right now, the first thing, of course, that you need to do is create an AWS account. So if you just search up AWS sign-in or Amazon Web Services sign-in and click on that link, it should lead you through the process of creating an AWS account if you just press create new AWS account. So you can work through that while we go over the next few slides before the demo. So we should also go over the use cases we're going to be using. So the first one is blueberry yield. Both use cases are from datasets we found on Kaggle. So for blueberry yield, our input features are information about specific blueberry fields, like the bumblebee density of the field and the proportion of days it rained during the season. And then we're trying to predict the total blueberry yield. Our second data set is about the adoption rate of animals from an animal shelter in Austin. And our input features are information about each animal, like their species, age, and breed. And we're trying to predict the outcome of their stay at the shelter, which can be adoption, being transferred, euthanized, and other options. Finally, we should quickly go over what S3 is because we'll be using it a lot. So we just want to make sure everyone's on the same page. And this might be obvious if you've used AWS before, but just to go over it, S3 stands for Simple Storage Service. And it's basically just where you store your files in AWS. To get a bit more into the technical details, it's an object storage service where objects are your file and your file's metadata, like when it was last modified and permissions for the file. In S3, data is organized in buckets, and within your buckets, you can have folders and files. S3 is used to build a data lake, which sounds scary, but it's just a platform to store and process large amounts of data that can automatically scale, handle different file formats, and you can control access to your files by assigning different permissions to different user roles. So for the examples that we'll be going over, our input data will be stored in S3, and SageMaker's generated output will also be sent to S3.
With SageMaker Clarify, we can generate statistical bias reports for both input data and model predictions. So these reports highlight any potential bias present in the data or model and provide actionable insights to mitigate it. So the tool offers several pre-built metrics and algorithms for bias analysis, as well as customization options to suit our specific needs. So to use SageMaker Clarify, we have two options. The first option is to leverage the SageMaker Clarify API, which allows us to integrate bias analysis directly into our machine learning workflows. So the API provides a convenient way to automate bias detection and monitoring. And the second option is to use the SageMaker Studio interface, which provides a user-friendly environment for exploring and analyzing our models. So with the SageMaker interface, we can access the full range of SageMaker Clarify functionalities through a visual interface. So just a quick overview of the SageMaker Clarify process here. So first of all, SageMaker Clarify is a tool, again, to detect bias and explain model predictions. So first step it does is it'll collect and prepare the training data. Then it'll train and tune model with the data that we provided. Once it's done tuning the model, you also have an option to deploy the model. And at the end, in the SageMaker dashboard, you'll have an option to monitor and see what the model predictions is in real time or in batch predictions. So now that we talked about Clarify, let's talk about what SageMaker Data Wrangler is. So using Data Wrangler data selection tool, you can quickly access and select your data from a lot of popular sources like S3 bucket that Hadas mentioned. SageMaker Data Wrangler gives you a data quality and insights report that we're going to go over later. So that automatically you can verify data quality, such as like missing values, duplicate rows, and data types. Once you can effectively verify your data quality, you can quickly apply your domain knowledge to process data sets for ML model training. So the Data Wrangler helps you understand your data and identify potential errors in extreme values with a set of robust pre-configured visualization. Now that we've gone through some of the important tools that we're going to use today, let's go ahead to the demo part of the workshop. So here in the slides, we've included the link to our folder. You can access later or follow along, but we have all the resources available in this folder here. So first thing we're going to do is create a S3 bucket where we'll upload our data. If you go to the S3 dashboard of Amazon, you'll see a button to create bucket. So once you click on that, this little configuration page is what you'll see. So the name can be anything as long as it's unique following the bucket naming rule. Just make sure you choose your own AWS region. So right now I'm in Korea, so I chose the Asia Pacific AP Northeast 2 for my bucket. So once it's created, you'll see it in your dashboard. In order to upload your local files, you need to drag data files. Once it's been uploaded successfully, if you click on your bucket, you'll see your data. So for today's demo, I've uploaded test and train data for blueberry yield already and create a screenshot here. And now that we have successfully uploaded our data to S3 bucket, we're going to go to the SageMaker dashboard. So at top right corner, make sure you're selecting the right region again. Now on this page, we're going to click on Create a SageMaker domain. Once you click on it, it will then take you to a page where you can set up your domain. For simplicity, we're going to click on Quick Setup. So here, you just have to make sure you have a unique domain name. At the bottom, you'll see a user profile section. If you click on the drop down for execution role, you'll see an option to create one. And then this is what you'll see. Because we don't want our user to have access to any other buckets, I've specified the S3 bucket name to be AWS AutoML demo, what we've created earlier. And once it's created, this is what you'll see. That's all you need to know to set up a SageMaker domain. Once you create a SageMaker domain, you'll see that its status is pending. It takes a little bit of time, so please be patient. So if it keeps saying pending after 3 minutes or so, you can try to refresh, but this is what you'll see when it's in service. We want to click on the domain we just created and go to the studio. So Amazon SageMaker Studio is an integrated development environment, so IDE, that provides a single web-based virtual interface where you can access purpose-built tools to perform all machine learning development steps. So creating Jupyter server also takes a little bit of time. Once it's created, this is the page you'll see. We're now interested in data in particular at this point in time. And then click on the Data Wrangler. Before we do anything, we want to import data that we uploaded in S3 bucket. Click Amazon S3 where we uploaded our bucket. So we're now going to import our blueberry train data from the bucket we uploaded. So here we can create analysis based on the pre-training data. There's actually many different analysis types SageMaker can create. So it can generate reports like bias report, feature correlation report, and data quality and insights report. So here, because our focus is on making an inference on yield attribute, we choose regression as our problem type and yield to be our target column. So the report generated from previous slide, you can use a report to help you clean and process your data. So it gives you information such as the number of missing values and the number of outliers. And if you have any issues with your data, such as target leakage or imbalance, the insights report can bring those issues to your attention. So for some reason, when I created a report, it gave me as a PNG, and I thought it was hard to go through, so I took screenshots of the report instead. So at the very top of the report, it gives us the summary of the data set we're working with. The insights report has a brief summary of the data that includes general information. So like, again, missing values, invalid values, feature types, outlier counts, and more. It can also include high severity warnings that point to probable issues with the data. So please check and investigate the warnings if you have any. When you create the data quality and insights report, Data Wrangler gives you the option to select a target column. So a target column is a column that you're trying to predict, right? When you choose a target column, Data Wrangler automatically creates a target column analysis like here. So it also ranks the features in the order of their predictive power. Like I mentioned, when you select a target column, you need to specify whether you're trying to solve a regression problem or a classification problem. So obviously not in this case, but for classification, Data Wrangler will show a table and a histogram of the most common classes. So a class is a category. It also presents observations or rows with a missing or invalid target value. So here it shows the distribution of our target column yield. So Data Wrangler uses Quick Model to estimate the predictive quality of a model trained on your data. So it splits your data into training and validation folds, with 80% used for training and the rest for validation. In classification problems, it ensures the same ratio of labels in both folds for better accuracy. So Data Wrangler trains on XGBoost model using default hyperparameters. So it also applies early stopping on the validation data and performs minimal feature preprocessing. In Data Wrangler's feature summary, so the features are ranked based on their prediction power. Prediction power is determined by training separate models for each feature on the training data. And it measures their performance on the validation data. So the scores are then normalized to a range of 0 to 1. So higher scores, so that's close to 1, will indicate more useful features for predicting the target variable on their own, while lower scores suggest less predictive features. So typically, if a feature doesn't show predictive power on its own, it's unlikely to become predictive when combined with other features. So you can probably rely on the prediction scores to find whether a feature in your dataset is truly predictive or not. A low score often suggests that a feature is redundant or not relevant. So a score of 1 indicates perfect predictive abilities, which could be a sign of target leakage. Target leakage happens when a data set contains a column that is not available at the time of prediction. So like duplicate of the target column might be 1. So by understanding these prediction scores, you can assess the usefulness of features in your dataset and figure out any potential issues like redundancy or target leakage. Finally, it shows you the feature details for all attributes. So here it talks about whether it has any missing values. So here it's the fruit set, and it tells us what the skewness is and feature distribution.
Okay, so now we're also gonna go over how to create and read a statistical bias report using SageMaker Clarify. First, though, we're gonna go over some examples of what statistical bias in your data can look like so we can better read the report. The first example we're gonna go over is class imbalance, or CI for short. Class imbalance is when one group in your data is represented at a much higher rate than another group. For example, in our animal data set, we only have cats and dogs. So if there were way more cats in our data set than dogs, that would be an example of class imbalance. This is bad because models trained on this data will learn a lot more from the overrepresented class than the underrepresented class, and will be worse at making predictions for them. There's the formula that SageMaker uses to quantify class imbalance. So n sub A is the number of data points from one class, and n sub D is the number of data points from another. We're aiming for a value near 0 because values towards 1 or -1 indicate that one of the facets has more training samples in the dataset. The second type of statistical bias we're going to go over is called difference in positive proportions of labels, or DPL. The purpose of this statistic is to determine if a class has a higher proportion of positive outcomes than another class. So for example, for our animal data, if 80% of female animals get adopted, but only 30% of male animals get adopted, that would be an instance of a higher DPL. So there's the formula that SageMaker Clarify uses for DPL, where QA is the proportion of positive outcomes for the first class or class A, and QD is the proportion of positive outcomes for the second class. So in our example, if we have 80% of female animals getting adopted, so we have QA equals 0.8, and then 30% of male animals getting adopted would set QD to 0.3. So our DPL value would be 0.8 minus 0.3, so it would be 0.5. So we can see that DPL values closer to 0 indicate less of a difference in the proportion of positive outcomes, and values farther from 0 indicate more of a difference. It's important to note, though, that a higher DPL is not always a bad thing, since difference in outcomes for different feature values are what drive model training. The use case in which we would care about DPL is where there might be historical bias or prejudice against a group reflected in our data that we don't want our model to be trained on. Obviously, this isn't really relevant for our animal data or blueberry data, but might be relevant for other models. Now that we have a good idea of what statistical bias can look like, we're going to go over to the code for how to generate the statistical bias report, and then we'll also take a look at the report. So I'm just going to open VS Code. One moment. So if you're following along with the resources we shared in the folder, this is going to be in the Blueberry Clarify notebook. But we're just going to go over how we can call the Clarify API to see how to generate the report. So the first step is just to import some libraries we need and to create a SageMaker session. And then the next thing, there's a few objects we'll need to create before we generate the report. So the first one is a SageMaker Clarify processor object, and the purpose of this object is to just define the scale of our problem. So here we're gonna define the number of nodes in our cluster and then the processing capacity of each node in the cluster. And we also pass in the SageMaker session that we defined earlier. The next thing we need to define is our data configuration in a data config object. So this is just so that SageMaker Clarify knows where your input data is and where to output the bias report. So you can see here, we're saying our input path is the path in S3 where we have our training data. And then we're specifying our output path for where we want the bias report to be within S3. And then when we create this data config object, we just pass in our input path, our output path, and we're also specifying that our target variable is yield, the columns or feature names in our data, and just the data set type. This next part is, I guess, the slightly more complicated part, and that's the bias config object we need. So earlier, when we were talking about examples of statistical bias, it was always about comparing classes. For something like our blueberry data, where the data, and especially the target variable yield, is continuous, we're going to have to define a threshold to kind of separate what we define as a positive outcome versus negative outcome. So for the purpose of this report, we've defined a yield over 5,000 as a good yield and a yield of less than 5,000 as a negative outcome or bad yield. So that's why here we've passed in as label values our threshold 5,000, because 5,000 is our threshold for a positive outcome for yield. And then for the statistical bias report, we only check one feature or facet at a time for statistical bias. So we've chosen to analyze average raining days. So that's why we've passed in average raining days here. And again, since it's a continuous feature, we'll have to define a threshold for the different classes we're considering. So here we're going to be comparing when average raining days is above 0.1 versus below 0.1. So again, average raining days is just the proportion of days it rained during the season. So we'll be comparing fields where it rained at least 10% of the time and fields where it rained less than 10% of the time. And our last Our last step is to run the pre-training bias job. So we're just running that on the processor object we created earlier, and we pass in our data config and bias config. And then we also specify what methods of statistical bias that we want to check for. And so here we're passing in CI and DPL just because we just talked about it. And I also wanted to mention that you can create statistical bias reports not only for your training data, but you can also run them after you've trained a model on your model predictions to check for bias in your model predictions. One last thing I should mention, or a few things, I opened this in VS Code, but really you would open it within a notebook instance in SageMaker Studio that Soyeon showed us how to open earlier through the SageMaker dashboard within your domain. And you just also might be wondering why we would go through the trouble of writing this code when we could also create this report through Data Wrangler in the UI, like Soyeon showed us for the other type of SageMaker Clarify report. You can really do both. There's no wrong answer. In terms of the free tier, though, for example, I think the pricing for a notebook instance versus Data Wrangler look a bit different. So if you're using both, it's just different resources being used. So that could be a benefit of using notebooks sometimes and Data Wrangler sometimes. So let's go over and see what the outputted report looks like. I just have it open here. So a great thing about this report is that you don't need to know anything about how it was configured because it explains it all again here. So here we can see that we chose yield as our outcome label in the input data, and we're saying a yield over 5,000 is a positive outcome. And here we can see the distribution of yield. It peaks between 5,000 and 6,000, I'd say. And then we also see that we chose average raining days as our facet to analyze for bias. It also explains a bit about the range of average raining days. So we can see it ranges from around 0.06 to 0.56. And we're saying we're comparing when average raining days is above 0.1 with all other inputs, so just below 0.1. We also see the distribution of the values for average raining days. It's a little bit difficult to read though. The next part, it also explains what different bias metrics you could check for. So here we checked for CI and DPL, but as you can see, there are a few other ones you could have also checked for. All right, so this part is the most interesting part. We can see the values for our bias metrics. So for class imbalance, we have a value of negative 0.53. So we can also see in this graph up here that there's a lot more data with average raining days above 0.1 than below. So we know that our model probably works better for blueberry fields that get more rain, and that explains our negative CI value. As for DPL, we get a positive value of 0.222, which isn't too far from zero, but it does mean that there's a slight difference in the fraction of positive outcomes, so yield over 5,000, between data with average raining days above 0.1 and less than or equal to 0.1. And the last part of this report is just the configuration parameters that we passed in when we ran the pre-training bias job. So just everything we saw in the code. So the methods we checked for, what our thresholds were, what facet we chose. And that's all for the statistical bias report. So let's go back to the slides. I think here, I also have the steps written out here for the code and what exactly we did. So after the workshop, you can go over this on your own in more detail, but here it's just explaining all of the steps I also went through in the notebook. Okay, so now we're going to move on to the second part of the demo, which is for SageMaker Autopilot. This is a really cool tool in my opinion because of the wide variety of things it can do for you. This picture illustrates it pretty well, but basically all you have to do is upload your raw data to S3, define what your target feature is. So in our case for the blueberry data, it would be yield, and for the animal shelter data, it would be the adoption outcome. Then Autopilot will analyze your data for you and generate information about any anomalies in your data or what might be missing, and it will feature engineer your data so it's ready to be used to train a model. Then it will train several models and compare them using different error metrics to give you the best model recommendation possible. SageMaker also makes it really easy to deploy an autopilot model to an endpoint, and it can even automatically deploy your best model. There are two things that I really wanted to highlight about Autopilot. So the first thing is transparency. So a great thing is that Autopilot will fully explain everything it does at every step of the machine learning process. As we'll go over, it generates a lot of different notebooks explaining the data analysis it does, as well as the feature engineering steps it takes, what kind of models it's going to try, and even which hyperparameter ranges it's going to use for tuning. So you fully know exactly how it gets its results, and there's just no mystery in how Autopilot works. The second thing I wanted to highlight is how customizable it is, depending on how involved you want to be in the process. So one way you can run Autopilot, which is the way we did it, is you can just make Autopilot do everything for you, and it'll complete all the steps I just mentioned. But you can also be a lot more involved at any step. So one example is Autopilot produces the feature engineering code it uses, so you can change it yourself and apply different transformations if you'd like. Autopilot also generates a transformed version of your training data after feature engineering has been applied and stores it in S3. So you can also train your own models using the transformed data. And so just use that part of Autopilot rather than having it also train models for you. Even further, Autopilot generates what they call a candidate definition notebook, which we'll see soon. But basically, a candidate is each suggested pre-processing step, algorithm or model, and hyperparameter ranges. Usually you specify how many candidates you want Autopilot to come up with, and you can use the candidate definition notebook to only run code for the candidates you're interested in, or you can run them all, and you can also change or tweak the code for each of them however you'd like. Okay, let's move on to the demo to see how we can actually run Autopilot.
Switching back to demo, here we choose a way to sample our data. There are many other sampling methods we can use other than none. So first case systematic sampling is one, random sampling is another, and stratified. But here, because we want to use the entire data, so I chose none to be the sampling method here. And now here, we want to export our data to select and train our model. We need to specify where we're getting the data to train a model with SageMaker Autopilot, so we choose where we stored our training data earlier. So once we export the data successfully, we can name our experiment. So here we actually want to say no to, is your S3 input a manifest file? Each line in the input manifest file is an entry containing an object or a reference to an object to label. So we want to split our data into training and validation. So we pick yes to auto split. So by default, Autopilot splits the specified data set into 80 to 20% splits reserved for training and validation, respectively. And here again, we choose our target column to be yield. So here we pick auto here for training method and algorithm. Autopilot automatically chooses either ensembling mode or HPO, so the hyperparameter optimization based on your data set size. So if your data set is larger than 100 megabytes, Autopilot chooses HPO, otherwise it chooses ensembling mode. So hyperparameter optimization, HPO method, Autopilot finds the best version of a model by tuning hyperparameters using Bayesian optimization or multi-fidelity optimization while running training jobs on your data set. So HPO mode selects the algorithms that are most relevant to your data set and selects the best range of hyperparameters to tune your models. And the other method, ensembling, Autopilot uses the AutoGluon library that we didn't go over today. So it uses that library to train several base models, and to find the best combination for your data set, ensemble mode runs 10 trials with different model and meta parameter settings. So now there's also an option to specify the type of machine learning problem. like I mentioned before, but here I've set it as auto, but there is auto, binary classification, regression, and multi-class classification. So once you click next and review all the settings, then you can create the experiment. Also, make sure to create the auto deploy endpoint name. We then review all of our configurations and create experiment. So once you click create, it'll show you the training progress. It doesn't really tell you how long it will take to complete, but it gives you like all the steps that it's going to go over. So right now it's in the pre-processing step, and now it's next it's going to go to the candidate definitions generated, feature engineering, model tuning, explainability report generated, insight report generated, and deploying model being the last step. And after a little while, it then produces a candidate generation notebook and data exploration notebook Hadas is going to go over in a bit. So once the training is done, it tells us what the MSD, RMSD, and the MAA values and its status is. So at the top, it'll show us the best model and the algorithm used. So we click on the deploy model button to deploy the best model. If you do decide to deploy the model using your free tier account, please make sure you choose the instance that is supported by the free tier. I'm not really sure if MLM5 4x large is supported by the free tier, but just double check whether it is. For deploying and making predictions, we have a couple of options. So for persistent real-time endpoints that make one prediction at a time, use SageMaker real-time hosting services, so pick real-time predictions. So real-time inference is usually ideal for inference workloads where you want to have real-time interactive and low latency requirements. To get predictions for an entire data set, you want to use SageMaker batch predictions. Use batch predictions when you need to pre-process data sets to remove noise or bias that interferes with training or inference from your data set, or if you want to get inferences from large data set, or if you want to run inference when you don't need a persistent endpoint. So you want to associate input records with inferences to assist the interpretation of results when you use batch predictions. Once deployed, you can go back to your SageMaker and see that its deployment has been completed. And the output file here, so the output file uses a .out extension. I suggest using Python's open function to open the file and investigate output values, whether it makes sense or not.
So now we're going to go over the output I was talking about, which will get stored in S3 once the autopilot job that Sayan just showed us is finished running. So first, we're going to go over the data exploration notebook. So I'm just again going to open that in VS Code. So this is the one for our Blueberry data. So we saw a lot of this in Data Wrangler when we were creating the first SageMaker Clarify report. There's a lot of overlap between the two tools. So the first thing it shows us is a data set summary. So we can see the number of rows, columns, what our target column is, if we have any duplicate rows or missing target values. One leg up though that it does have is that it will automatically detect our problem type if we choose. So here is detected that our problem type is regression. If we jump over to the data exploration notebook for our animal data set, we can see that this looks a little bit different. So here we can see that it's detected that our problem type is multi-class classification, which is right. Going back to our first data exploration notebook, if we scroll down a little bit further, we can again see target analysis, which we saw in Data Wrangler. We can just see a few different statistics about our target column yield, like mean, median, minimum, as well as a histogram of the target column labels. If we look at the animal data, this looks a bit different because it's a different kind of problem. So we can see here we can see a histogram of the different possible outcomes. So as we can see, most animals get adopted, which is great, but we can also see the other types of outcomes here. And it even gives us a warning saying there's skewed label frequency. So it's saying that the label died only appeared 197 times in our data set, which is much smaller compared to other labels. So it's basically saying that any model we train is probably not going to be great at predicting when animals die. So that's just useful information for us to know, and I believe it also gives some tips on how to solve this. So going back to our first notebook, we can also see just a sample of our data. So just a few rows from our data set. Again, we can see prediction power, which we saw in Data Wrangler. And so we know for our blueberry data fruit set will probably be very important to predictions. And we can also see the column type, which Autopilot infers from our data. So for our blueberry data, all of our columns are numeric, which you can see. Can I scroll through this? Yeah, they're all numeric. If we look at the animal data, we can see that they're not all numeric. So we can see that they're categorical columns, text columns, date, time. So it does look a little bit different. The data exploration notebook will also tell us if we have any duplicate rows, which we don't. And then the next part is cross-column statistics. So this just tells us the correlation between different columns in our data set. So basically darker blue means a higher correlation, lighter, like closer to white would be less correlation. And this is especially useful to know if there's some redundancy in our data. So for example, here we have both raining days and average raining days, when really this is just the same information, just on a different scale. So we'd probably remove one of these from our data set. And as we can see, they're very highly correlated. The next part of the data exploration notebook is anomalous rows. So this is just to point to if there are any possible errors with your data collection. So Autopilot has a way of giving an anomaly score, and it's just to ask you to check out to make sure the data makes sense. So this is something you definitely require more domain knowledge about, but maybe someone who's more of an expert with blueberry fields would be able to tell if this data all goes together. Like maybe, for example, they would see that this clone size, the 37.5, doesn't really make sense with this bumblebee density. Obviously, I'm not too sure about that, but it's just really to check that there are no errors in the gathering and processing of your data. The next part is missing values, which we don't have any, so that's great. And then for cardinality, it's just explaining how for your string features, if it decides if it's categorical or text. So this is a little bit more relevant for our animal data because all of our features are numeric for our blueberry data. So if we jump to that part for this notebook. So basically the way that it decides if it's categorical or text is just the number of unique values for the string features. So for something like, for example, breed or color, there are just way too many unique entries to make that a category, so it's going to treat it as text. But for something like sex upon outcome or outcome type or animal type, they have a lot less unique entries, so it's going to treat that as a category. So we can jump up to the data description just to confirm that. Yeah, so we can see sex upon outcome is categorical, but something like breed is text, or color and name are both text, just because there would be way too many categories if it was treated as categorical, and it wouldn't really give us useful information. And finally, at the bottom of both of these notebooks, we have descriptive statistics about each one of our input features. So we have, just for all of our columns, the percent of numerical values and just some information about the range of values it has and if we have any outliers. And also at the bottom, this is an information about our data, but it's great because it just gives definitions of all of the technical terms that are used. So you don't really need to have too much technical knowledge going in because it explains what numeric means, what categorical means, binary, text, date, time, and it explains the different statistics it uses and how they're calculated, which is really great. So now we're going to go over to the candidate definition notebook now that we've looked through these data exploration notebooks. So I'm just going to close those. So we're going to go over the candidate, oh, sorry, wrong notebook. This is the candidate definition notebook for our Blueberry data, which we're going to go over. Again, to properly run this, you would want to open in SageMaker Studio. But the first thing we need to do is just some SageMaker setup and just making sure S3 is configured. This is all in the folder shared, so you can go over this in more detail on your own after. And the interesting part is the candidate pipeline. So as I was mentioning before, a candidate is the pre-processing steps it recommends, the model it wants to train, and then the hyperparameter ranges. So it actually splits it up into first pre-processing and model, and then hyperparameter ranges. So the first part, so here we'll see DPP0 XGBoost, for example, is our first candidate, and it explains which pre-processing steps it wants to follow. So robust imputer, and then robust standard scalar. And then it's saying the transformed data will be used to tune an XGBoost model. And it just gives the definition of that candidate. And we'll see that for all of our candidates. So here, this is also for an XGBoost model, but the pre-processing steps are a bit different. If we keep scrolling down, we'll see all of our candidates before the hyperparameter range part. They're not all XGBoost models though. So for example, here it's a linear learner model. Before we move on, I just also want to reference what I was saying before when I was saying you can edit the feature engineering code if you'd like. So for example, our first thing here, DPP0, we see it explains that it uses robust imputer and robust standard scalar. And this code is outputted to S3. So I have it open here. But as you can see, it's going to apply robust imputer and then robust standard scalar. But if you wanted to edit this a little bit, you could, and then apply whichever pre-processing steps you would prefer, and then just save the file and rerun it. I'll just quickly show you where that's stored in S3. So if we go to our bucket, where we just define where the output would be for our autopilot job, and then we're going to go to SageMaker AutoML candidates, and then generated module, and then candidate data processors. And then to see, we'll have a Python file for each of our candidates. So the one I was just showing you is DPP0, but you could edit any of these to your own specifications. And I also mentioned earlier that feature engineered data is available. So after these steps have been applied, so you can train and tune your own models. So I'll show you where that is. So if we go back to just the output file for the entire job, that'll just be under transform data. And then we can choose which pre-processing steps we want followed, for example, DPP0. And then just under here, we'll have our training data and validation data ready to go for model training if we want to use it that way. So if we jump back quickly to our candidate definition notebook, I can just show you what the hyperparameter tuning looks like. So if we scroll past all of our candidates here, quite a few of them, then it explains how you can execute them. And then we can see the hyperparameter tuning ranges. So here, like you can just go in and change this code to the static hyperparameters that you would rather use. So if you want a different k-fold value, you could just change it here and then rerun the cell. And then you can also change the hyperparameter search ranges it's going to use in here. And then I believe at the end of this notebook, it also guides you through the process of deployment. So if we keep scrolling down, all of these cells are just to actually run the candidate pipelines. Yeah, so model selection and deployment. So it'll just run you through how you can select your best training job. And then if you run all of these cells, you can deploy your best candidate pipeline. So now we're just going to go over the generated reports from Autopilot. So if we jump over here, after your model has been trained, it'll produce a model quality report as well as an explainability report. So first we're going to look at the model quality report. This is for our Blueberry data. So it'll generate one of these for each of the trained models. So we can see this is for the weighted ensemble L2 full candidate. And it just explains that it's a regression model and the objective is to minimize the mean squared error or MSE error metric. So it explains a little bit about the job. So just the Autopilot job name, what candidate we're using, what the problem type is, objective metric, how we're trying to optimize, we're trying to minimize the MSE, and then it'll explain the values of different error metrics. So we have mean absolute error, mean squared error, RMSE, and R2. And we can see what the values are for this model and the standard deviation. It'll also provide us with a few different plots so we can visually see how our model's doing. So we can see an actual versus predicted plot to see how close the actual and predicted values are. So closer to our line of best fit, the less model error there would be. And we also have that same information in a standardized residual plot where the idea is the same. The closer to the line it is, the less model error there would be. The last thing is a residual histogram, and it's great that AWS explains all of its output. So for example, even for the first two graphs, if you weren't sure how to read it, there are explanations. So for the standardized residual plot, it measures the strength of the difference between observed and expected values, and it just gives information about how to read those values. For me, I didn't know what a residual histogram was, so it's great to read this explanation here. But we can see that if it's distributed in a bell shape and centered at 0, it indicates that the model does not systematically over or under predict any particular range of target values. So reading this, looking at our histogram, we can see that it's basically bell-shaped and centered at 0. So this is a good sign for our model. If we jump over to the quality report for our adoption data, it looks a little bit different because it's a different kind of problem, but the main idea is the same. It explains which candidate the model quality report is for, what kind of model it is. So it's a multi-class model, and we're trying to maximize the accuracy. And again, we just have the details of the autopilot job. And then we have the values for our different error metrics. So weighted recall, weighted precision, as well as a few others. And we can just see their values in standard deviation. The next part, since this is a classification problem, is a confusion matrix. So basically here we can just see the predicted labels versus the actual labels. So ideally, if you've seen a confusion matrix before, so this is if it's predicted as adopted versus actually adopted, we would want a diagonal dark blue line across here because that would mean that all of the actually adopted animals were labeled as adopted, all the animals that died were labeled as died, and so on. But so here from our confusion matrix, we can see that our model is only really good at telling when animals are adopted, because we can see this is dark blue for adopted and adopted. And the rest it isn't great at, which makes sense from our data because we had a lot more data points where animals were adopted versus for other categories. And that's it for the model quality report. If we go over to the explainability report, it's going to explain our predictions. So for yield, for our Blueberry data, it's explaining how we predict yields, and it's just giving our SHAP values for the different features. So SHAP values, we're not going to go over how they're calculated, but the basic idea is same as prediction power, where it's just explaining how important each feature is to the overall prediction. So here we can see, as we saw in prediction power, that fruit set is the most important feature to explain yield, and then seeds, and so you can see the relative importance of each of our features. So again, this kind of report would be generated for each model that Autopilot outputs. Our explainability report is a little bit more complicated for our adoption data because it is a multi-class classification problem. So here we can see the global SHAT values. So we see that overall age and sex are the most important for determining what the adoption outcome is. But if we scroll down to the different labels, we can see that it kind of varies depending on what it is. So again, for adoption, we see age, sex, and then time that we're checking are the most important. But for example, for animals that died, age becomes more important, or before it was sex, which makes sense because probably animals that are older are more likely to die. Another example is for return to owner. We can see that name becomes suddenly a lot more important than it was before, probably because animals with names are more likely to be returned to their owners. That's all for the explainability report, and that's all the output we're going to go over for Autopilot today. So if we go back to the slides. Again, though, if you do want to go over these resources in more detail, they are in the folder we shared. So the last thing we want to go over is if you do want to learn a bit more about AWS, but you don't want to make your own account, or even if you do want to make your own account, there's also a really great free platform called AWS Educate with courses and labs that you can learn more about how to use different AWS tools with. So it's not only for machine learning and AI, although that is one of the topics, but you can also learn more about analytics and cloud computing in general. So here in the screenshot, we can just see a few of the courses it offers within machine learning and AI. But it's a really great tool and completely 100% free. We've also linked a few more resources here. So the AWS documentation itself is really great for learning more about SageMaker in general, as well as Autopilot and Clarify. And we also recommend this course from Coursera called Analyze Datasets and Train ML Models Using AutoML, because there's a lot of really helpful information there about how SageMaker works. That's all for our presentation today. Thank you so much for listening.